Let's invite the Director of Switch Product Management Department of H3C, Mr. Chen Bochao, and his topic would be the high-speed networks carrying 5G services.
Dear guests online, and today I would like to share with you the high-speed network that carries the 5G business. 5G is closer to us now, and I believe that you are looking forward towards its coming. And the standard of a 5G has been set in 2018, and in China, we have started to build a large-scale network of 5G, and we believe that in 2020 it will be fastly implemented and popularized. Apart from bringing the convenience for our life and the driving force for our national economy, actually it has brought unprecedented challenges for our digital infrastructures. How can we regard these challenges? We can start from the three key technology points. First, the endpoint rate. In 2G, we can just visit the internet through the mobile terminal. And for every versions of the network, we can increase the rate of our terminal. And in 5G, we can enjoy the 1 GB per second connection rate. And second would be the massive connectivity of a 5G. The 5G can achieve over 100,000 terminals connection within 1 square kilometers, and this has provided a great support for us. Third, we can have a look about the key applications of 5G. First, based on its improved bandwidth, it can provide us with this kind of AR, VR, the online teaching and the teleconference, this kind of applications with high requirement of the bandwidth. Second would be the massive amount of Internet of Things like the smart home, the smart city, and this kind of connection of things. Thirdly, the 5G has a low latency characteristic, which makes it quite suitable for the drones, the remote medicine, and the automatic driving. So actually, all of these applications have raised high requirements for us. Our commonly seen infrastructures would be the DCI data center and the 5G barrier network. As for the data center, actually, it is kind of stored, calculated, and delivery key node for the large amount of data. It needs to provide high bandwidth and also needs to have the ability of to have a kind of easy to be extended. And secondly, as for DCI, it needs is to have the kinds of high bandwidth and high specification to achieve this kind of complicated dispatching of the multi-cloud platforms. And that would be the 5G barrier network. We need to introduce the network slicing, this kind of technology. So how can we solve among these three scenarios the challenges brought by 5G network? We can see that among these three scenarios, they have a common requirement that would be the higher bandwidth. In the last version of the Ethernet, the 500G has been popularized for a long time. And next would be the 400G. It has been proposed for a long time. Because at the time there wasn't the requirement. With the coming of the 5G, it has brought us with a very good opportunity to implement the 400G. If we want to achieve the AR and VR, we need to have the high bandwidth. Also, in the ICT infrastructure, we are doing the evolution of the other functions like the high capacity storage, etc. So the coming of the 5G has provided the core requirements of the 400G network and has fastened its implementation. Secondly, even though we have set a standard of that in advance, but we need to have a long-term technology accumulation to fully implement this technology. We need to have our chips and the mature programmability of these chips, as well as the processing capability of that. And also, we need the physical, the protocol, as well as the other business modules to provide this kind of holistic technology system to fully implement these products and these technologies. H3C as the leading enterprises of network in China. On the one side, we can have a accurate insight of the requirements of the industry and the clients. On the other side, we have a long-term technology accumulation. So before the coming of 5G, we have proposed and promoted these whole series of the 400G internet switch, which includes the kind of S9825, 64 CD, and the S9855, 32 CDF. So for all of these products, how can they solve the challenges brought by 5G era? Let's continue. First of all, let's have a look about the data center. It has been divided into the internal part of data center and DCI. We can find that within it, our terminal that is server, it has some fundamental changes. For example, its storage from SSD to NVMe to SCF. This kind of change is changes and its operation system. So from the machine to the virtual machine, all of these technologies, the ultimate goal is to improve the throughput capacity of the single server. Once it has been improved, our internet access layer needs to improve its rate. Currently, we have the 100G server, and we will definitely see the 200G server. So today, our 98553.2F, it can be dispatched into two 100G. So actually, for the single machine, it can satisfy the demands of multiple machines. Also, it can be connected with our core switch. And actually, these would be the highest performance core switch in this industry. These two core switch and over 30 of the access switch, they can achieve a quite good capacity. And by utilizing this model, you can have a good standard of your data center and to solve the high bandwidth and high scalability requirement of the data center. And in the DCI scenario, as we have mentioned, we need a kind of equipment that has a higher performance of the single machine. That is the 12500. This machine, it can support over 4 million routers. And in DCI, H3C, together with many of the large internet companies in China, we have done a long-term cooperation to cope with the complicated business dispatching demand under this scenario. And third point would be our 5G barrier network, this scenario. Actually, the main network structure has been identified. We can see that in its backbone, we have adopted this 400G standard. And with the development of 5G, maybe in the access and aggregation link, it will further develop towards the 400G. Apart from the high bandwidth, operators also focus about the network slicing capacity. The kind of SRv6 is a key technology because it has multiple innate advantages. First, it is quite easy to be deployed because it is update of the IPv6 and to utilize the protocol message head of IPv6, like the VX line, EPVN. Those protocols on the original message headers to achieve this kind of channels. But for SRv6 is a kind of original and standard IP protocol, and which has a quite simple protocol. From the WAN to the data center, we can deploy a set of the network. And second point is that it can be fully integrated with ICN. It is a standard protocol, so that for different devices of different clients can be connected within it. So our previous complicated protocol cannot do this. And lastly, it has a high scalability because SRv6 used the message head for every of its field. It has 128 bits. Previously, it only has 32 bits, and which can only accommodate the root. But for SRv6, for each header, it can be divided into locator and function. These two fields to define the address and the operations. So if we can fully use these 128 bits, it can provide a really good programmability, and operators can use the machine to dispatch a more complicated and multi-layered SRv6 text to achieve this kind of end-to-end bandwidth protection and the low latency protection, as well as the complicated business isolation, this kind of network slicing demand. So the 400G together with the SRv6 would be the key technologies for the 5G barrier network. And whether the SRv6 would be the perfect technology, we can see that for its advantage actually is also the reasons that why it has a current dilemma, that is the 128-bit. We know that for the network slices, if you want it to be more flexible, you need to have multiple headers to achieve it. And if we have multi-layers of the message headers, which means that you carry less of the business data. So the business volume that it can carry has been a problem for us. In the last version of the network, the operators requires us to have a certain level. In a 5G, we can have a look that for a typical 5G access network, we have this amount of the machines. If we want to across so many nodes, we need to have more message headers of multi-layers to notify the definitions of your complicated business. So for 10 or even over 10 layers of the message headers is not a goal, long-term goal for the network, for the operators. So we know that from these slides, if it reached 10 layers of the message headers, the efficiency quite low, only have 57%. So even though it has achieved 400G ports, but actually volume of efficiency is only equals to that of the 200G. So for H3C, as the technology leading enterprises in this industry, we have identified these issues, and together with our partners, we have developed this SID technology, and which can compress the originally 128 bits into 32 bits. So we can have 4 headers, and we can improve the efficiency. We can see that after using the unified SID, under the 10 layers of the message headers, the loading effect can reach the SSR plan. The good point is that first, it can improve the efficiency. Secondly, it can have a smooth transition with the previous network. And also, we are the first in the industry to achieve that in the ASIC chips, to achieve the 400G plus the SRv6. So this has raised a new solution for us for the 5G barrier network. We know that the ASICs routers cost is much lower than our current router, so we have proposed a lower cost solution for our operator partners. And under the unified ID standard setting procedure, our H3C has played many of our advantages. For example, we have set this kind of compressed algorithm which has defined how can we compress the 128 bits into 32 bits, and also all of the clients can identify it, which is quite difficult. Secondly, we have redefined the UFUNCT, this header, and which can just connect these two networks, and these two key technologies has been defined officially. Also, we have fully displayed the advantage in switch for ASIC to do the kind of SRv6
400G forward procedure, because previously these are achieved through the MP programmable chips. And how can we achieve this kind of 400G SRv6 transferring and forwarding? This would be our key technology points. Also, how can we help all of those chips to find all of those messages and do the fast forwarding? This would be our key technology breakthroughs. And we have become the first in the industry, merchants in this industry, and we have achieved the initial testing with our operators in order to further testify our whole forward capability, and we have done a kind of 400G performance test of the 10 layers SRv6 tags together with our partners. And now we would like to introduce to you this kind of most difficult internet test to you.
So let's invite Mr. Nigel Wright, the Global Vice Executive President of Spirent, to share with us the joint test of H3C together with Spirent. Now let's welcome him.
First, let me congratulate H3C Group on the convening of the 2020 Navigate Summit. H3C has been a leader in the Ethernet switch market since it was established, and Spirent and H3C have had a long and productive working relationship. In 2017, Spirent and the H3C conducted a 768-port, 100 gig full line rate performance benchmark on the H3C S12500 Ethernet switch that set an industry record for scale and performance. This year, we again had the honor to do a performance test, this time on H3C's latest 400 gig switches. As we all know, SRv6 is a slicing technology that's key to building a 5G transport network for resource use efficiency, programmability, and end-to-end service assurance. Testing SRv6 with 400 gig Ethernet performance at the same time can fully validate the practical value of the hardware platform in 5G business. In this test, we used the latest Spirent Test Center 400 gig tester along with its latest SRv6 test suite to conduct the industry's highest density 400 gig SRv6 flow test. Building on H3C capability to deliver SRv6 line rate forwarding on 400 gig programmable ASIC, the test results showed that the H3C S12500 switch series can forward SRv6 packets with a 10-label stack at line rate on 36 400 gig Ethernet interfaces on a single slot. And this test again set a record for scale and performance, indicating that the H3C S12500 switch series can be deployed as SRv6 forwarding nodes on any 5G transport network to deliver high forwarding performance. On behalf of Spirent, thank you for the opportunity to participate in this record-breaking test. Congratulations on the tremendous performance capabilities of H3C switches that it confirmed, which should help H3C become an even more important force to drive infrastructure growth in China and throughout the world. Thank you again and enjoy the summit.
And thanks for Mr. Nigel Wright's excellent speech.
So through these above-mentioned introductions, you can find that actually the 400 gigs a switch can satisfy the challenges brought by the 5G era, and our IS12500XCF can support the 14 layers tags and can achieve this kind of 5G barrier network, the backbone node standard. So our two core switch through their high-density performance, can solve the flexible scalability and greatly reduce the energy consumption of data centers. So in the three scenarios, our three devices can cope with the challenges of the 5G era. So the 400 GHz switch of the H3C would be the best choice of the 5G era. We believe that with the development of the 5G era, H3C will follow the trends of this industry and to promote the products with better performance to satisfy the demands of this era. And let's welcome the coming of this 5G era. Thank you for your attention.